Hello, we are continuing our study of mechanics, and today we are going to talk about two very important concepts such as kinetic and potential energy. So what is energy in general? This is a very important subject of study of physics because when we talk about processes, about some phenomena that occur around us, we must necessarily remember that all this happens with the application and explanation in terms of the concept of energy. For example, when such a phenomenon as melting of ice occurs, for instance, you took the ice out of the refrigerator and you see that it has started to melt, we must necessarily understand that ice receives a certain amount of energy, due to which certain changes occur. And of course, many different processes in mechanics can also be connected with the concept of energy. For example, the elementary falling of a drop of water from the sky to the ground is also accompanied by processes of change and attraction of energy. Today our task is to get acquainted with these two concepts and to determine the formula by which we can calculate these types of energy. So, energy in general is some physical quantity that will determine the state of a given body or system of bodies. Depending on what kind of energy we are calculating, we will talk about different situations, and the first situation that will be connected with kinetic energy is motion. Any moving body has a certain energy, in this case kinetic energy. How to determine this energy? Let's try to give such an example. The body, under the influence of a certain force, begins to accelerate and acquires a certain speed at a certain interval. Let's say it had some speed at the beginning, which is not zero. And after a while, the body, under the influence of this force, which continues to act on it, has a certain final velocity, which is also not zero. In this case, the body is accelerating. A certain acceleration will be necessarily present. And here it is possible that there is either acceleration of this body or its deceleration, that is, both of them we can consider here. What can we use to describe this situation? Of course, we can consider this problem from the point of view of Newton's second law, because there is a force, there is a certain mass of the body, and there is a certain acceleration. So, now our task is to try to describe these moments and see what we can use here to calculate our problem. So when we talk about the action of a force and a certain displacement is produced by this force, we can talk about the work that has been done on this displacement. We define work as the product of the force and the corresponding displacement of the body. We already know what the force is. It's the product of the mass of the body and its acceleration. And then the question arises, what is the displacement of this object? Here we can remember different formulas by which we determine the displacement of the body, and let us remember this formula when we know that the body moved with some acceleration, had some initial velocity, had some final velocity. But suppose we do not know the time for which the acceleration of this object occurred. Then it is very convenient to use a formula in which we don't have time, that is, we don't need to look for it, and we can substitute it into our expression. Then we get the following expression. So we've written the force, we've written the displacement, we've multiplied it. And we see that here acceleration is reduced, and now let's try to transform a little bit mathematically the obtained expression. To do this, we divide each square of velocity by 2 and then multiply by the mass. We end up with the following expression. Mass times the square of final velocity divided by 2 minus mass times the square of initial velocity divided by 2. We got that the value of work is determined by the difference of two sum parameters. That is, it is certain some expressions that we need to understand what will be. If we remember another definition of work, very important, which you and I will have to use not only in mechanics but also in other sections of physics, namely that work is a measure of change of energy. That is, depending on what happened to the body, what force acted, what work it did, all this led to a change in the energy of this object. And the work, by its definition, will just define the change of energy of this body in this case the change of kinetic energy, because the motion of this object has changed. Then we can say that the kinetic energy of this body at any moment of time will be defined by the formula as the product of the mass of the body by the square of the velocity, and all this is divided by 2. Let's write down this expression separately. So we'll denote kinetic energy as Ki, and so the formula will look like this. I remind you that this is the energy of motion, and it is related directly to the speed of motion of the object. And of course we must mention that this energy is relative. That is, everything will depend on what reporting system you consider the calculation of this energy, because it is related to speed, and speed, as we remember, the value of relative. So we pay attention to which report system you are in, and relative to which report system you are asked to determine this type of energy. That is, in the calculation, we must necessarily take into account that speed is a relative quantity, and accordingly, kinetic energy will also have a relative character. And so we have familiarized ourselves with the energy of motion and immediately designate the unit of measurement of this energy. Let's make a certain calculation what kinetic energy will be measured in. For this purpose, we multiply the mass, i.e. kilogram, by the square of velocity. Meter squared divided by second squared. And you and I have already seen this expression, which actually has with it a new physical quantity, which you and I have become familiar with in past lessons, which is called joule. That is, energy is also measured in joules, and as well as work has the sense of accumulation of a certain resource, the potential of the body, and it will be used in calculations of these parameters. So, let's move on. Now the next type of energy, which is also very important for analyzing many phenomena and which describes the state of systems, and not only consisting of one body but maybe many bodies, is the interaction energy. When bodies interact with each other, then, we say in this case, certain forces appear. For example, we are attracted to the Earth, and in this case the force of attraction acts on us. But we should not forget that exactly the same force acts in this case also on the Earth. That is, this is a two-sided interaction. And as a result of this interaction, there is not only the force of attraction, there is also the energy of this attraction. That is, each type of interaction in nature has a certain type of energy. In this case, it is potential energy. And depending on the type of interaction, there can be many types of such energies. You and I will look at these types of interaction depending on the topic we are going to go over. Today we will get acquainted with the first type of interaction. It is the energy of attraction of a body to the ground. How do we calculate it? Here we can use a fairly simple situation where a certain object is lifted by a certain force to a certain height. And consider the situation when we lift the given body without acceleration, i.e. slowly. With a small speed, the given object rises. In this case, we have to say that this is possible if the force that we exert on the object to compensate for the force of gravity acting on this body. So in this case, we would write the compensation in this way, and then the work that has been done by this person, for example, who lifts this body will be determined by the product of the force on the displacement of this body. Well, and accordingly the force will be equal in this case to the force of gravity. Thus we have received the formula for calculation of work on lifting of the given body. And if to think now from the point of view of energy on what this work has gone. This work was done to lift this body to some height h, that is to give it some energy, in this case potential energy. Again, we say that here there is no change of kinetic energy, i.e. the velocity of the body remains unchanged, constant. Then the potential energy of this object will be defined by the formula m by g by h. It will also be measured in joules, because we see here the same product of force on displacement as well as the work itself, which we have taken here as a basis for the derivation of this formula. So the two types of energy that you and I have been introduced to today are kinetic energy and potential energy. These are two components of one energy that a body can have. It will be called total energy in this case, and we will learn about how this energy behaves in our next lessons. That's the end of our lesson. We'll see you now in practice. Goodbye, everyone.